Earlier in the year, we talked about the Pythagorean Theorem, which deals with right triangles and how to find a missing side of a right triangle. And if you remember, in a right triangle, we have two legs, which are next to or adjacent to the right angle, and we've also got our hypotenuse, which is across from the right angle. And also, if you remember, we called the two legs A and B, and it doesn't matter which one's which, A and B. And we called the hypotenuse C. And the Pythagorean theorem says that the length of A squared plus the length of B squared gives us the length of C squared. And we talked about two kinds of examples, one where we were looking for the hypotenuse and one where we were looking for one of the legs. So let's talk about this one with the hypotenuse first. I'm going to write my formula again, that A squared plus B squared equals C squared. And looking at my triangle here, C is the hypotenuse, that's what we're looking for, and then 5 and 12, that's A and B, or the legs. And again, with A and B, it doesn't matter which one is which. So let's go through and fill in the information that we know. So 5 is A, so 5 squared, plus 12 is B, 12 squared, gives us C squared. 5 squared is the same as saying 5 times 5, which is 25. And 12 squared is the same as saying 12 times 12, which is 144. And we've still got that C squared. 25 plus 144 gives us 169 as a value for C squared. Now you're not done yet because 169 is the value for C squared. But I just want to know what C is, what's the length. And the opposite of squaring a number is finding that number's square root. So to undo that C squared, I'm going to find the square root of C squared. If I find the square root on the right side, I have to do the same thing on the left. So I have to find the square root of 169. Now I've just got C over here, which is what I'm looking for, and the square root of 169. If you remember, the square root is saying what number times itself will give me 169 in this case, and that number is 13. So the length of our hypotenuse, or our side C, is 13. Over on the right, we have an example where we know the hypotenuse, but we're looking for one of the legs. So we're going back to our same formula. A squared plus B squared will give us C squared. And looking up at our triangle, 13 is across from the right angle, so that has to be the hypotenuse, or our C. And we're looking for B, so that means this 5 has to be A. So let's go back and fill in the information that we know. A is 5, so 5 squared. I don't know B squared yet, so I'll leave it as B squared is equal to, C is equal to 13, so 13 squared. Now I've got 5 squared is 25, plus B squared, can't do anything with that yet, is equal to 169. Now we've got one extra step here. This is a two-step equation. And so remember, we're doing those order of operations in reverse. So the first thing that I want to do is get rid of this 25. Let me change colors here. So I want to get rid of this 25, and the opposite of this positive 25 is minus 25. And if I take away 25 from the left, I have to also do that from the right. 25 minus 25 is 0. Or now I just have B squared on the left. And 169 minus 25 is 144. And now we're back to where we were in our first example, where we've got B squared, but I want to know what B is. So I'm going to take the square root of each side. And the square root undoes the square, so I'm just left with B. And the square root of 144, or what number times itself is 144, is 12. And so in this example, side B, or leg B, is equal to 12.